Hi everyone. In today's class, we'll see one of the asynchronous counter, that is a mod 6 counter. Guys, you know what is the meaning of mod 6 counter, right? Mod 6 counter means it is going to produce the values from 0 to 5. 0 to 5, right? I mean, if I am going to have the value 0, then I will get the value 1, then 2, then 3, then 4, then 5. Again I come back to 0. This is what you can call it as mod 6 counter, right? So if you would like to construct this mod 6 counter, actually if I am going to have 2-bit counter, meaning that if I am going to have 2 flip-flops, I can get mod 4 counter. If I am going to have 3 flip-flops, I am going to get mod 8 counter. But here they are asking the counter which is between the 4 and 8. How can we get? Can I take the 2.5 flip-flop? No. Can you take the 2 flip-flop? No. So you have to compulsory take 3 flip-flops. I mean, when you are going to construct any kind of a flip-flop, any kind of a counter which they are asking according to the requirement, you have to select the counter which will satisfy this requirement. So here the best possibility to implement the mod 6 counter is you require minimum 3 flip-flops. Am I right? Yes. 3 flip-flops. Guys, if I take those 3 flip-flops, try to analyze. If I take those 3 flip-flops, for example, J0, K0 and J1, K1, J2 and K2, and for all this we are going to anyway pass the toggle value 1, and you are going to pass the high clock signal, that is negative edge clock signal. Yes, done. If I am going to pass the negative edge clock signal like this, what might be your answer? Let me know, right? So we have seen various kind of examples, right? Q0, Q1, Q2. We have seen various kind of examples. If you are going to understood, this is QA and QB and QC, right? So which is acting as a kind of mod 8 up counter. That's good, fine. But the point is they are asking only for mod 6 counter. What we can do, right? Guys, if you try to observe here, for clock, I will try to write in other side. If I am going to have the clock and QC, QB and QA, if I try to draw the table for this, 0th clock signal, you are going to get 000 initial values, 1 0001, 2 010, 3 011, 4 100, 5 101, 6 110, 7 111. Okay, fine. So if you take the mod 6 counter, actually you are going to get the values. Next, from the next time onwards, they are going to be repeated. Again go with the 0. But here according to the given requirement, they are asking for us to construct only mod 6 counter. Mod 6 counter means you have to go with 0 to 1, from 1 to 2, 2 to 3, from 3 to you have to go with the 4, 4 to you have to go with the 5, then you have to come back like this. I mean, so what you have to do, guys, when you are going to get QC, QB, QA values are 110, or if you are going to have 111, for these cases, for either 110 or for either 111, what you have to do, you have to set these values to again 00, so that can it be converted to a kind of mod 6 counter. Even though you are going to have 3 flip-flops which may yield to mod 8 counter, we are trying to make these two values, 110 and 111 into 000. Can we do that? Yes. How can we do this? See, observe. If I try to replace these values with 00, guys, is there any concept that we have seen earlier? earlier, can we change any kind of flip-flop value to our own required value? Earlier we have seen certain kind of conditions. One is preset state, another one is clear state. If you remember it, these two are the kind of commands that we have used while working with asynchronous flip-flops, right? Meaning that irrespective of type of input what we are going to have, they are going to doesn't consider them. They are going to simply do what they are requested, what the command is going to perform. I mean, if we have given this like example clearly there itself, you can go through that. I will try to write here. See, basically you can go with either active low or active high, right? I would like to go with the active low. If I go with the active low, if preset and clear are some kind of things, what might be the QN? That is what I am trying to write here. If preset and clear, one is 0, another one is 1, you are going to get same high state. If it is 1, if it is 0, it is going to clear the state. If both are 1 1, it is going to work normally. If it is a kind of 0 0, this state should not happen, right? If you want, you can go with how asynchronous JK flip-flop is going to work for both positive triggered or edge trigger flip-flop. You can go through that video. Okay, now fine. Now try to observe, guys, what we are thinking here. If we are going to have the values of 11110 or 111, you have to change this flip-flop values. You have to change this flip-flop value to 0. You have to change this flip-flop value to 0. Similarly you have to change this flip-flop value to 0. Can we do that? Yes. How can we do this to 0? By simply making connect some kind of clear command. If I made the clear command equal to 0, what will happen? Every time it is going to produce always 0. But we don't need always 0. We need only at a particular instant of time. What is that particular instance of time? When the states are 110 or the states are 111. At this point of time only you have to check them. Right? So can you do any can you get a solution? See, can you able to generalize anything? So if I try to think about it, so I can do it in many ways, but the simplest way is if you check when QC value is 1, QB value is 1, or when QC value is QB value 1, I would like to make it reset state. Am I right? So simply what I will try to do now, I will try to make use of one AND gate. When QC value is 1, QB value is 1, and when 1 and 1 is 1, but you have to pass here the value as 0. So I am going to simply use a NAND gate. Guys, if you take out any of these cases, it is going to be failed. This extra circuit is going to be failed. I hope you understood. This extra circuit is going to be failed. So here, if you consider QC value and QB value, if I pass here 0 0, it is going to produce 1 at the output of this side. But there is a special case when QC value is 1, QB value is 1, then only you are going to get the value as 0. At that time, these flip-flops are going to get the value as 0. So this is the way you can able to change it. But the thing is, in the reality, there is one more kind of a thing is there, right? Preset is also going to be there, right? So if you take any flip-flop, so far we are not we didn't get any kind of requirement where we need to use clear as well as preset. But in this particular scenario, it is required for us to use clear and preset. So that's the reason we have it, right? Now what does the values of PST values? You have to make them as 1. That's it, right? Yes. So this is the corresponding mod 6 counter which we can use, which we can get it through the circuit diagram. Here few people may got the doubt like how can we directly constructed this NAND gate with the help of only QC and QB, right? So basically the point is these 6th number and 7th number are unique, because if you take any kind of numbers between the combination of QC and QB, there are no such numbers which contains both are ones. That's why I have taken directly to identify them uniquely. Or else if you want, we can go with the K-maps where you can able to solve it, right? So try to observe. I will try to take the K-map for solving this one. If I take QC, QB and QA, so we are going to have 8 values, right? So 0 1 0 0 0 1 1 1 1 0, right? Guys, here for what thing we are trying to construct like circuit we are trying to construct it for active low, right? So as I am trying to construct the circuit for active low, what about all these values? These all values like basically 1, values basically 1, right? And for this value I have to make them as 0. This is the value I require. So if I place them, so 000 we are going to get 1 0 0 1 1 0 1 1 1 0 1 0, yes, 1 0 0 1 0 1. So up to here we need all the ones. And what about 1 1 0 1 1 0 is 0. And from this place onwards you can take the value of anything, right? Yes. So what we can do now, if you try to combine these two into a single thing, I can get the value as, see guys, as it is active low, I am going to construct the product of the sums. It should be opposite, right? So what we can do, we can get it as, so what is not changing? Only QB is not changing. QB is not changing. So that too, it should be QB bar, right? As it is 1, so it is active low state, it should be opposite. If it is in active high state, it should be QB only, right? QB into, this is also 1, right? So means QC bar. I can write it as QB into QC, which is whole complement, right? So QB into QC whole complement, I can write as QB into QC whole complement. That's it. The same thing I mentioned here also. Right? This is the way you got the thing. Okay, fine. Thank you.